Hi, I'm going to start out with, would you like to hear a story? I hope so, because we're going to start with a real life story, a Cinderella story that began in an underfunded institution called Carl Hayden Community High School in Phoenix, Arizona. The underdogs in this story, four undocumented students of Mexican heritage living in the United States who joined a robotics team. Except this robotics team, as you can see, was different. Instead of competing with wheeled robots that drove on a course the way that we drive cars, this competition totally takes place underwater. They designed a remotely operated vehicle, an ROV, that has to accomplish specific tasks in a simulated environment in a pool. With a pretty Spartan budget, under $1,000 is what they were able to raise for their team. Carl Hayden Robotics scrounged, pulled parts from junkyards, from wherever they can find them, asked for donations, and built their robot pictured here called Stinky. Their smelly beast of an ROV that was built out of PVC and parts and chemicals that made it really kind of smell, so they called it Stinky. So they could find those parts in like local home improvement stores, junkyards, things like that. With a national competition in California looming, the teammates Oscar, Luis, Lorenzo, and Christian, they decided to enter in the college level division. Being a high school, they decided to go for a college division because if they lost, well, they were supposed to lose to colleges. There would be less, they would lose less face. If they went against high schools and lost to all the high schools, then that would mean that they're pretty much a bad high school. If they lost to colleges, then it was kind of what they were expected to do. So during the engineering evaluation of this competition, which incidentally is called the MATE competition, the Marine Advanced Technology Education Center, judges investigated the team's knowledge of engineering principles, their design choices, budget considerations, among other details. The typical budgets were like MIT, $18,000 that they were spending on their robot. Cornell University spent $11,000 on their robot. And when the judges asked Carl Hayden what their budget was, Christian replied, oh, about $8,000. And the judges assumed that they meant $8,000. But in actuality, they had spent about, well, just under $800. So long story short, this ragtag A-team of underwater roboticists from an underprivileged community in Arizona won the entire national competition against MIT, Cornell, Virginia Tech, some of the best engineering colleges in the world, spending 1/20th of the budget of MIT and using creativity, innovative thinking, and just verve to overcome the obstacles and persevere for the win. Now, their story was later covered in Wired magazine in an article by Josh Davis in May 2005. That kind of vaulted them to a certain fame inside the robotics community. And then eventually it was made into a 2015 feature film called Spare Parts. I totally recommend this film for educators. It's a film that it's a tearjerker. It will bring tears to your eyes. So that film starred George Lopez, Marissa Tomei, and Jamie Lee Curtis. And definitely, if you can put it on your Amazon list, do so. Because after all, who does not love an underdog story? So my name is Damian Baraty. I have just completed my 21st year teaching in private schools, my first year at the Severn School in Severna Park, Maryland, and this is my 28th year in education. A majority of my years I've spent doing different robotics platforms and microelectronics. I've done teacher training at the National Robotics Education Consortium in Pittsburgh, learning Lego Mindstorms robotics. I've done Lego Mindstorms training in Legoland in Carlsbad, California. I've attended 3 times the Marine Advanced Technology Education Center's summer ROV program for teachers, and I'm a Raspberry Pi certified educator. So I've had like some great experiences and been able to follow up and incorporate a lot of different styles into my robotics. So my Set Lab project, planned, aided, and abetted by my mentor and managing editor here, Vicki Steinwurtzel, has really evolved into a different type of project and presentation. I named it Underwater Robotics Programs, the Northwest Passage to STEM, because I've been exploring using underwater robotics to teach students about solving real-world engineering problems as opposed to the more traditional approach of using terrestrial, wheeled, or tracked robots that would operate inside some type of field. Educators who are considering starting a robotics team or STEM program but may not really know where to begin, they represent my target audience for this research. I'm hoping that this SET Lab research project will provide a guide for teachers to get started on a pathway that will benefit their students and train them for a future in STEM specifically, or for just having kids live in a technological world that is really evolving and innovating every day. I mean, everyone has to start somewhere, and you know, if I can help people get started on that path, that is kind of the goal here. So there are many different robotics programs out there, and they all have different costs, different investments required. Some are really sold as package deals that, you know, is more oriented towards making money for a company. Others are more grassroots efforts that really focus on the education. Some cost more than others, some cost a lot more than others. Some have kits that cost over $5,000 to $6,000 just to get the parts that you need to compete. And others you can use with you know, hardware or robotics parts and equipment that you might have at home, or maybe you have a Lego Mindstorms kit that costs maybe $250, and that's enough to get you started. So how does one find the right program for your particular group, your particular kids, whether you're doing an after-school program, an in-school curriculum, summer camp? There are really just so many options out there, and I am not going to be complete and try to cover every robotics program out there, but I've selected a few to kind of give you an idea of, you know, a little bit about my path to coming into underwater robotics and focusing on underwater robotics, and some of the options that you have there. So the framework that really kind of informed my pathway, my voyage from the Lego wheeled robots to my current fascination with using aquatic robots in the classroom and in summer camps, everything. It really started with a visit to the Florida Educational Technology Conference, which is one of the largest educational tech conferences or tech conventions in the country at the time, which was the 2000s. One of the meeting spaces was devoted to a FIRST robotics competition team. So FIRST is a organization that was started by Dean Kamen to really kind of promote STEM and STEAM careers, and try to get corporations working with schools to really put forth engineering as a and technology and computer science and math as fields to get kids excited about. So at FETC, they had a workspace where some of the kids from the FIRST program had set up their robot that was able to pick up and shoot basketballs. And so they have a pretty complex task. And this robot was about the size of a dishwasher or a refrigerator. So I started asking questions because I think it was really impressive to see a robot that can pick up and shoot basketballs and actually score baskets. It's really impressive. But then I started talking with the students, and I wanted to know like how the robot worked, how they built it, how they controlled it, how the control systems work, things like that. The response was underwhelming. The students seemed to be there kind of just as drivers and basically props, while the building of the robot was affected by a team of adults from a corporate sponsor who provided engineers and mentors to work with the team. With a timeline of 2 months to build a robot, basically January and February, and costs ranging from about $5,000 just for the kit up to $50,000, which is what some teams spend in order just to be a competitive robotics team in this competition. A school-based group might find it really challenging to devote the time, financial, and personnel resources that you need for such an enterprise. Now, this is not to say that all students in the FIRST program work that way, or that students don't get a lot out of this program. I'm sure there are many great FIRST programs where kids get a lot out of it, but it really got me thinking that there should be programs where the focus should be on the students exploring, planning, engineering, testing, and adapting designs to solve problems, not merely working alongside professionals who might do this for a living. I think that's great, but I think it's more important that the kids are the ones who are able to do the work. FIRST has raised the bar, definitely in the United States and outside the United States, for providing recognition and excitement around STEM fields. And it does reach over 500,000 kids in the United States and around the world. So it definitely is a dominant force in the world of robotics. A second formative experience is a short film titled Two Ball Games. James B. Moss, who is the former chair of the psychology department at Cornell University, and my professor in Psych 101, he produced this video that showed two different ball games to our psych class. One was a neighborhood pickup baseball game that is juxtaposed with a nearby Little League baseball game, replete with umpires, coaching staffs, and official uniforms. The Little League game shows tense videos of arguments between the coaches as the players look on from the infield, an altercation with a fan who actually storms out into the field to confront the umpire and has to be asked to leave, lots of yelling from the stands, a win or lose mentality that was just adding to the pressure of the kids, and stressed out kids on the verge of tears even after they had won and would advance to the playoffs. The local pickup game shows the neighborhood friends putting down paper plates to figure out how to do some bases. They're working together, they're having disagreements and having to work them out person to person. And they even had to work together to retrieve the ball when it rolled into a storm sewer, and they had to remove the grate in order to get the ball back. At the end of the day, one of the neighborhood kids didn't even have a clue who won. I had a preference and sought out robotics activities that were kid-centric, where the young people had to solve problems, implement solutions, and explain their decision-making while working in teams the way that they will work in the real world. In the robotics program that I coach, which is the Marine Advanced Technology Education Center, the MATE Center, I am not allowed to turn a screwdriver or write code for the robot. All of that has to be done by the kids. All of that has to be done by the student team members, who basically form a corporation that have divisions of labors, responsibilities, different roles like president, chief technical officer, chief financial officer. I act simply as a coach and advisor, making sure that they work safely and learn the skills they need to succeed, and that they have the resources that they need to develop their system. So I set out with a set of 3 aquatic robotics programs, asking to speak to program coordinators about the mission, the reach, so how many kids they reach, the guiding principles, and the effectiveness of their programs. But first, what are the main types of robotics programs getting kids involved in STEM fields? So I went over a few of the terrestrial ones. There's a wide range of competitions and platforms that deliver these kind of wheeled or terrestrial robots to kids. I was looking at a few: FIRST Robotics, Vex Robotics, Lego Mindstorms, and Bot Balls. All of them are similar in that they compete in a rectangular grid, and they have to basically simulate different tasks like picking up a basketball or throwing a frisbee or using an arm to hit a switch. These differ because they can be different sizes. They can be about the size you see here, that's about the size of a dishwasher, and there are other ones that could be the size that could fit inside the shoebox. While there's plenty to learn in simulated robotic playpens, there are 2 frontiers that have captured people's imagination. 2 final frontiers, really. So in space, Star Trek's Final Frontier, we have seen major accomplishments of late, with Elon Musk's SpaceX Dragon rocket successfully returning astronauts to the International Space Station, and basically opening up a new chapter in space exploration, with American rockets bringing American astronauts back into space, the first time since the retirement of the Space Shuttle program. The second realm is under the sea, which also requires engineering in environments with incredible stresses and changes in pressure, and navigating in a complex 3D environment. So this quote from How Stuff Works is already out of date. They note that there are only 3 people who have descended to the deepest part of the ocean, an environment that we know very little about. The actual number is now up to 8 people. This is the 8th person who has been to the deepest part of the ocean, so Challenger Deep. Her name is Dr. Kathy Sullivan. She's a NASA astronaut and administrator who has been, and she is the first person who has been into space. She was into space twice on 2 space shuttle missions. And she's also been to the bottom of the ocean, about 33,000 feet down. So she's the first person to get into both of those extremes. This happened 8 days ago. So this is basically a realm that is just being explored. All right, so I checked out a couple of alternative programs, and I was looking at these main 3. The Mate ROV competition is the one that I do. There's another one called Sea Perch that is coordinated with the Office of Naval Research, so they get a lot of sponsorship and time from the U.S. Navy, and they also have a corporation behind them called RoboNation. Water Robotics is the 3rd one. This basically uses Lego Mindstorms, but is kind of defunct. It's kind of not being used that much right now. So this was my process. To investigate the programs, I collected information on websites, then I interviewed. I was able to actually interview the directors of these different programs and get a lot of firsthand information from the people who are running the organizations. So I'm really grateful for the time that they were able to do that. The takeaways, I was able to make a couple of different spreadsheets and collate all of this data into a giant spreadsheet where we were trying to compare and contrast the different pros and cons, the prices, the costs, what it costs for teacher training, and how much you'd have to invest to get this program started. I was comparing also how many students are reached by each of these programs each year. So for FIRST Robotics, it's about 500,000 kids. And some of the other programs like MATE, the one that I focus on, is a little bit less than about 10,000 students. So definitely a little bit smaller. So there's a lot of different ways that you can compare these things. The end result though was this kind of flow chart that if you start at the top and ask yourself some different questions, you can basically kind of focus on maybe some of the programs that might be very helpful to you. So one of the first questions was, do you want to work on land or on water? And that would lead you to more questions that can help you refine your program's goals, what your budget is, and what might be a suitable program for your kids. So the call to actions that I have down for educators, you need time. There needs to be time in the schedule or after school programs or summer camps in order to expose kids to these different skills. It takes time, it takes effort, it takes money in order to get these programs together. But with certain programs, you can do a lot with just what you seem to have on hand or what you can scrounge. Other programs require more money and more resources. Call to action for leaders. Figure out the best program that fits your school. Your teachers, your instructors definitely need training, they need support, they need backup. For many of these programs, the training is provided for free. You can find the training out there. It doesn't have to cost an arm and a leg, but it does take coordination in order to manage those goals and make things happen. The final call to action for policymakers, understand the benefits of what we're trying to do, what we're trying to build. These are important problem-solving skills. These are team-building skills. And these are the skills that are transferable. These are the skills that will transfer to the world of work, the world of everything after school. So you're really building the workforce of the future. Some of these programs were really, the genesis of them was starting with workforce preparation. In STEM, STEAM, these are ways that we can prepare people to work in the future, to work in teams, to work collaboratively, to work productively in the future. So in my ideal world, every school, every kid who wants the opportunity would have the ability to join in a robotics program. I hope that, maybe I've elucidated some of the pathways or some of the ways and some of the things that you should think about in coming up with or deciding what path to choose to go forward with some of these programs. But in an ideal world, yes, we would be able to reach every kid who wanted an experience like this to go ahead and attain it. So these are my thank yous. Thank you to Vicki and Irvi for all their coordination and support, and of course all the people that were able to give me time, taking time out of their organizations to explain to me their perspective on the missions and everything else, all the background information on these different programs. And this is just a final picture of that same team a couple years later. 2 teachers are on the outside, and the 4 kids who won the world championships in the Mate Center competition are pictured there in the middle. So that is my presentation.